Hello everyone, and then welcome to another video. Okay, so it seems that there's been some complaints about you guys not being able to hear my voice due to some technical challenges. Okay, I'm trying to fix that. Okay, so I hope you could clearly hear my voice in this video, and then let me know in the comment section whether my voice is really clear or not. Okay, right, so let's dive right into this video. So we'll be talking about systems of what, solving systems of what, equations using matrices. Okay, right, so we'll be looking at augmented matrix, and then we'll be also looking at what, Gaussian elimination. Okay, that's the row-echelon form, and then the Gauss-Jordan what, elimination, that's the reduced row-echelon form. And then I'll give you 3 pro tips. Okay, so I might not write these pro tips in this video, but I will leave them in the description. Okay, so that whenever I'm referencing to them, you just check in the description. Okay, and then read them, and then they are just 3. Okay, they are not really that difficult to understand. They are self-explanatory. Okay, so once you get that, you are good to go. Now let's look at what, augmented matrix. Okay, let's look at how we write augmented matrix. Okay, so in case you've been given what, a matrix in this form. Okay, let's say the matrix is in this form. Okay, so we have 3x1 minus 10x2 plus 6x3 minus x4, okay, equals 3, and then we have the second row and then the third row. Okay, so first you need to check the highest value of what, x. Okay, so from here we have what, x to be what, x4. Okay, the highest is what, x4. This means that we have what, 5 rows. Okay, we have 5 rows, and then we have, because we have what, 1 2 3. Okay, so it means that we have 1 2 3 4 5 rows. Okay, right, so once you note that, you could just write that straight away. Okay, right, so you could just write your augmented matrix in this form. Okay, so we have what, we have 3 over here, so this is the 3. For augmented matrix, we write the what, we try writing the coefficients out. Okay, keep that in mind. So we have row 1, row 2, and then row 3. Okay, and then we have what, 3 over here, that's this 3. Okay, that's the 3. Okay, and then we have minus 10 over here. Okay, and then we have 6s3, and then minus what, s4, that's what, negative 1, then we have what, 3. Okay, right, and then we move on to what, 1. Okay, and then we don't have s2. Okay, so you could notice that we have s3 over here, so s2 is what, is 0, 9x cube and 9s3, and then we have what, minus 5, and then what, 12. Then you move on to what, minus 4, 1. Okay, minus 9, 2, and then what, 7. So this is how we write what, augmented matrix. Okay, so now let's move on to what, row echelon, and then what, reduced echelon form. Okay, so this is how we write row echelon method. Okay, so for row echelon method, any value, okay, any value below the leading one, okay, below the leading one is what, has to be what, 0. Okay, but for reduced row echelon form, any value below or above the leading one has to be what, 0. Okay, so let me emphasize, let me try and elaborate on the leading one. Okay, so now the leading one, okay, the leading one is the leftmost non-zero value. Okay, leftmost non-zero value in what, in matrix. So okay, so we have 1, let's say 1 over here, we have 2, we have 3. Okay, and then 4. Okay, and then we have what, 0, 1, maybe 2, 3. Okay, this is an example, so you don't need to worry that much. And we have 0, 1, 2. Okay, so this is what, a row echelon form, because this is the leading one. Okay, leading one means that the value is 1, and then it's the leftmost non-zero value. Okay, so 1 is what, non-zero. It means that it's not a 0. The value for 1 is not 0, it's 1. Okay, so any value beneath the what, 1, the leading one has to be what, 0. So you will notice that we have 0 over here and then 0 over here. Okay, and then we move on to what, now this is the leading one, okay, of the second row. So we have the first row, and then we have what, second row. So the leading one in the second row is this value, okay, because it's the leftmost non-zero value, okay. So there's 1, and then anything below that 1 has to be 0, okay. So the same thing applies over here, right? So these are the leading ones. This is an example, okay. So this could be also 1, okay, but since it's an example, okay, it might change or not, but let me just replace that by 0, okay, since it's an example, just for illustration. So let's look at reduced row echelon form, okay. So reduced row echelon form, every value below and above the leading one has to be 0. So we have maybe 1, 2, and then maybe 3, and then 4, okay. So it means that we have 0, 0 over here, and then once we have 1 over here, this will change to 0, okay. So any value, this is an example, okay, so don't pay much attention to the values I'm changing, okay. I'm trying to write out a reduced row echelon form of a matrix so that you get to understanding other than just going by the explanation and all that, okay. So you might have maybe 2 here and then maybe 3, okay. This is an example, okay, so don't pay much attention to the values I'm just changing and all that, okay, right. So let's say this is a leading one, so anything over here has to be 0, okay. Keep that in mind, okay. It's very, very important, okay. That's for reduced row echelon form. Any value above or below the leading one, okay, these leading ones have to be 0, right. So let's move on to solving questions on systems of equation using matrices, okay. So let me give you the 3 pro tips, okay, and I will leave them in the comment section, okay, right. Let's look at this question, okay. So the first pro tip, there are 3 pro tips, okay. For the first pro tip, you don't need to make any value within the matrix a fraction, okay. Avoid fractions in within the matrix, okay. So, and then the second point is that whenever you are trying to find the leading one, okay, always multiply the row containing the set of values where you want to find the leading one by a suitable fraction, okay. I will solve some examples with you so that you get to understand, so that you get to appreciate it, okay. I'm just highlighting the pro tips you need to know, cool. Okay, so the first tip is avoid fractions within the matrix. The second tip is once you want to find the leading one within a row, you have to multiply that row by a reasonable or suitable fraction, okay, in order to arrive at the leading leading one, okay. And then the third pro tip is that in order to get zeros below a leading one, okay, in order to get a 0 or zeros below a leading one, that's for row echelon method, and then in order to get zeros below and above a leading one, that's the reduced row echelon method. You always add multiples of the row containing the leading one to the row in which you want to achieve the zeros, okay, right. So I will elaborate more on that, okay, so that you get to understand. So let's write the augmented form of this matrix first, okay. So we have to find the Gaussian elimination, okay. So let's write the augmented matrix first, okay. So we have -2, 1, okay, -1, and then 4, okay. And then we have 1, 2, okay, 3, okay. Let me rewrite this. It doesn't look like a 3 at all, okay. So we have 3, and then 13, and then we move on to 3. We don't have x2, okay. So we have 0, and then we have 1, and then we have -1, okay, right. That was really simple, okay, right. Now let's try using the row echelon method to find the respective values to the x1, x2, x3, okay. So we are using the Gaussian elimination to solve the following system of linear equation, okay, right. Let's proceed. So first things first, okay. First things first, we need a leading one over here. Okay, we need to have a leading one over here. So from here, you could, from the question, you could just notice that we could interchange row 1 and then row 2. Okay, so that we arrive at what? The leading one. Okay, so we have what? We interchange them. So row 1 and row 2, we try what? Interchanging them. Okay, once you interchange that, you will end up with what? 1, 2, 3, then 13. Okay, and then we have what? Minus 2, 1, minus 1, 4. Okay, and then we have what? 3, 0, 1, minus 1. Okay, we just interchanged row 1 with what? Row 2. Okay, so these are row 1, this row 2. Okay, we just did the changing. Okay, we interchanged them. Okay, so once you interchange that, you end up with what? A leading one over here. Okay, that's what the first step. Okay, that's our leading one. Okay, right. So let's proceed. So we have so this is our first step. Okay, we are just breaking this down to what? The row echelon method. So let's move on to the second step. Okay, so we maintain this, right? So we maintain that. So we have 1, 2, 3, and what? 13, and then we have what? Minus 2, 1, minus 1, 4. Okay, and then we have what? 3, 0, 1, minus 1. Okay, right. So let's see how we proceed. Okay, so now, since we have a leading one over here, so as the pro tip states, we have to make every value within the what? Or beneath the leading one. Okay, or the column within which we find the leading one, zeros. Okay, so anything beneath the leading one has to be 0. Okay, so how do we do this? And then I already stated that once you want to make any value, okay, beneath or under a leading one, okay, 0, all you have to do is just add a multiple of the row containing the leading one to the row in which you want to arrive at the leading one. Okay, so this is how we do that. Okay, so we could notice that we could add R2 to the 2R1. okay, when you multiply this row 1, okay, this row 1, this row 2, this is what? Row 3. So once we add row 2, since we want to make this value 0, we could add the whole of row 2 to 2 times 0, the whole row of what? Row 1. Okay, so we are concentrating on what? The row 2. So this is equal to what? This is equal to what? Row 2. Okay, so row 2 is equal to what? Row 2 plus what? 2 times R1. Okay, and then since we are making all these values 0, okay, we have to find a way to also make what? This 3 0. We have to convert that to 0, and then in order to do that, row 3, okay, will now be equal to what? The row 3 minus what? 3 times row 1. Okay, right. So this is how you could end up with what? A 0 over here. So let's try doing that. Okay, right. So let's try doing that. So we have let's maintain our what? Row 1. Okay, so we have 1, 2, 3, and then what? 13. But let's find what? Our new R2. So for R2, all we are doing is just adding our R2 value to what? 2 times R1. Okay, right. So you can just use a calculator to do that. Okay, so let's go through that. So we have what? R which is what? R2 which is what? Minus 2. Okay, so minus 2 plus 2 times what? R1. So 2 times R1 will give us what? 2. Okay, right. So we have R2, okay, equals okay, so we have what? R2, okay, plus 2 times R1. Okay, so once you compute that, so we have what? Minus 2. So over here we have minus 2 plus 2 times 1, which is what? 0. Okay, so we have 0 over here, and then we have what? 1, okay, 1 plus 2 times what? 2, that's what? 5, okay. And then we move on. So we have what? Minus 1 plus 2 times what? 3, that's what? Minus 5, okay. Sorry, that's what? 5, okay. That's positive 5. And then we have what? 4, okay, plus 2 times what? 13, okay. That's what? 30, okay. Right, so let's proceed. So for R3 we have what? The R3 minus 3 times R1, okay. So we have what? 3, okay. 3 minus 3 times 1, okay. That will give us what? 0, okay. And then we have what? 0 minus 3 times what? 2. That will give us what? Minus 6, okay. Then we have what? We have 1, okay, minus 3 times what? 3, okay. That will give us what? Minus 8, okay. And then we have what? Minus 1, okay. Minus 1 minus 3 times what? 13. That will give us what? Minus what? 40, okay. So we have what? Minus 1, okay, minus 3 times what? 13. That will give us what? Minus what? 40, okay. Right, so we've gotten what? Zeros for what? The values beneath the leading one, okay. So now let's proceed to the third step, okay. We are still reducing this to the what? The row echelon form, okay. So we have what? 1, 2, 3, 13, 0, 5, 5, 30, okay. 30, and then we have what? 0, minus 6, minus 8, minus what? 40, okay. So now let's proceed. So from here you can notice that we need to also convert this 5 towards a leading one, okay. So how do you do that? I've already given you the tip. Once you want to convert any value, okay, within the matrix to a leading one, just multiply the entire of that row containing the value which you want to convert to a leading one by what? A reasonable what? Fraction, okay. So what fraction can we use, okay, so that we could convert this 5 towards a leading one without ending up with what? A fraction. So the first pro tip is what? Avoid fractions, okay. So for simplicity, you've already guessed, okay. We have what? 1 on 5, okay. 1 on 5 multiplying what? R2. So our R2 will now be what? Equal to what? 1 on 5 multiplying R2, okay. So let's do that. So we have what? 1, row 1 will remain the same, okay, 13, but row 2 will change, okay. So we have what? 1 over 5 multiplying R2. So these are R2 values, okay. These are R2 values, okay. That's row 2. So we have 1 on 5 multiplying 0 will give us what? 0. 1 on 5 multiplying 5 will give us what? 1. 1 on 5 multiplying 5 will give us what? 1. And then 1 on 5 multiplying what? 30 will give us what? 6, okay. And then we maintain our what? Row 3, okay. 8, and then what? Minus what? 40, okay. Right, so now let's proceed, okay. Let's proceed. You could notice that this is very simple, okay. This has been well simplified, okay. We are still reducing the row echelon, okay, method, okay. So we have or form. So we have 1, 2, 3, 13. Then we have what? 0, 1, 1, 6, and then we have what? 0, minus 6, minus 8, minus what? 40. So now from here you can notice that yes, since this is a leading one, we have to make any value or every value beneath it equal to 0. So this has to be converted to what? 0, okay. Right, so how do you do that? I've already given you the tip. All you have to do is just multiply the row which is containing what? The leading one by what? A multiple, okay. You just multiply that by a multiple, okay. So all I'm trying to say is that you, for the row where you want to convert to a leading one, you add multiple of a row containing the leading one to the row in which you want to what? Convert to the leading one, okay. So yes, that means that we have to what? Pick a specific value, okay. and then multiply that to the row containing the leading one, okay, and then add that value to the row which is not containing the leading one. That's the simplicity, okay. Multiply a value to the row containing the leading one and add that to the row which is not containing the leading one, so that you could end up with what? A 0 beneath the leading one. Again, multiply a value to the row containing the leading one and then add that to the row which is not containing the leading one. Okay, so let's see how we could convert this to 0. So let's convert what? Row 3. Okay, right, so row 3 will be equal to what? Now let's multiply a reasonable value to what? To the row containing the leading one. Okay, so we can multiply that by 6. Okay, so row 2 is containing the leading one, so we multiply that by 6, and then we either add or subtract depending on what the values, okay, to the row containing the value we want to convert to what? 0. Okay, right, so here we go. So we maintain our first row 1 2 3, and then what? 13, and then what? We maintain our second row 0 1 1 6, and then we change our what? The arrow 3, the third row changes, so we have what? 6 multiplying what? Row 2. Okay, so that's what? 0. Okay, so 6 times 0, that's 0 plus what? Arrow 3, that will give us what? 0. So this 6 times 0 plus 0. Okay, 6 times this 0 plus this 0. Okay, and then we move on to what? This form. Okay, so we have 6 times what? 1. Okay, 6 times 1 plus minus 6. Okay, so that will also give us what? 0. Okay, right, and then we have what? 6 times what? 1. Okay, plus minus 8. Okay, so 6 times 1 minus 8. Okay, we will end up with what? Minus 2, and then we have what? 6 times what? 6 plus minus 40. Okay, so 6 times 6 minus 40. Okay, and that will give us what? Minus what? 4. Okay, right, you see how this simple this is. Okay, very very simple. Okay, so now let's proceed to the fifth. We are still reducing this to the what? Row echelon method. Okay, right, so we have 1 2 3, and then what? 13, and then we have what? 0 1 1 6, and then we have what? 0 0 minus 2 minus 4. Okay, so now we need to convert what? Minus 2 to a leading one. Okay, so again, once you want to convert to a leading one, multiply by what? A reasonable what? Fraction. Okay, so what do? We could multiply the whole of the row 3. Okay, the whole of row 3 by what? A reasonable fraction. The reasonable fraction which will end up with this portion of the matrix a value 0, or you could end up with a value 0 over here is what? A suitable fraction. See, so we have what? Minus 2 over here, so most definitely we could multiply what? Row 3 by what? Minus half of what? Row what? Row 2. Okay, right, so we have row 3. Okay, row 3. Okay, so we just do that. Okay, so it is row 3. Okay, row 3, we just multiply half of what? Row 3. Okay, and then we end up with what? A new row 3. Okay, a new row 3. So let's maintain our what? First row. We have 1 2 3, and then what? 13, and then we have what? 0 1 1 6, and then we have what? Now we want to find our new row 3. Okay, so all you have to do is just multiply the entire of row 3 by what? Minus half. So when you multiply minus half by 0, you end up with what? 0. When you multiply minus half by 0, you end up with another 0. When you multiply minus half by what? Minus 2, you end up with what? Positive 1. And then when you multiply minus half by what? Minus 4, you end up with what? Positive 2. Okay, right, you can see how simple this is. Okay, right, so let's proceed. Let's try writing this out. Okay, so let's try writing this out. So we know that we have the row echelon method or the row echelon form, okay, the row echelon form. So we write this back, okay, so it's like back calculation, okay. First we converted to augmented form, but now we are writing it in full, okay, like systems of equations. So we have what, x1, okay, we have what, plus 2x2, okay, plus we have what, 3x3, and then we have what, equal to what, 13, okay. And then you move on to this portion. So we don't have x1 over here, we have x2. So we have what, x2 plus x3 to be equal to what, 6. And then we have what, we don't have x2, we don't have x1, so we have x3, okay. Now we have x3 equals what, 2. So from here you can notice that we have x3 to be equal to 2, so we can just substitute that into this expression to get our what, x2, okay. So x2 plus what, x3, we know that x3 is what, 2, so we have what, 2 equals what, 6. So when you find x2, you end up with what, 4, okay. Now let's substitute this s2 into this expression. So we know s2 and then we know s3, so let's find s1, okay. So in finding x1, so we have what, x1 plus 2 times what, s2, which is what, 4, okay, plus 3 times what, s3, which is what, 2, okay, equals what, 13, okay. So we have what, x1 plus, we have 8, okay, and then plus what, 6 equals what, 13, okay. So we have x1 to be equal to 13 minus 14, so we end up with what, x1 being equal to what, minus 1, okay. So we have values for x1, x2 and x3. So we have x1, okay, x1 to be equal to minus 1, x2 to be equal to 4, and we have what, s3 to be equal to what, 2, okay. So this brings us to the end of this video, okay. So right, note that in our next video I will teach you how to end up with these exact values, okay, but by not going through this entire process of what, addition, subtraction, multiplying, and all that, okay. I'll show you a simple trick in order to arrive at the same answer, okay. Right, so thanks again for staying with me to the end of the video. Kindly subscribe, hit on the bell icon so that you don't miss out on any uploaded video. Share, and then let me know your comments in the comment section, okay. Again, let me know whether I've been able to at least solve the hearing problem, okay, due to the complaints I had earlier, okay. So I'll see you in the next video. Bye bye.